Okay, so let's discuss question number 4 now. A hammer is thrown straight up with a speed of 10 meters per second near the surface of the earth. We are asked to find out the maximum height reached by the hammer. And I gave you a hint, velocity at the maximum height is 0. By now, you know that. It is one of the conditions in free fall motion. At the maximum height level, the velocity of the object is 0. It comes to a stop at that point. Okay, so let's start by visualizing the problem. So this is the hammer, you throw it up. It's going to slow down while it's moving up. It's going to reach the maximum height. And we know that at this point, velocity is equal to 0. And it's thrown at a velocity of 10 meters per second. So v naught y is equal to 10 meters per second. And we also know the acceleration for an object that is in free fall is always equal to negative 9.8 meters per second squared. It's negative because we take our up as positive. Acceleration due to gravity is always downwards. So this is all we know. We know the initial position. We know the initial position. It's equal to 0. Y naught is equal to 0. Remember, I always ask you guys to take the ground level or the bottom level as the 0 position, and final y position, y is an unknown. If you know the final y position, y, that would be the height, maximum height reached by the hammer. Initial y position is 0. Now let's assume I'm going to use the equations, kinematic equation, the first one. I have no idea which one to use, so I'm going to just start from the first one. V naught y is equal to, Vy is equal to V naught y plus acceleration times time. What I'm trying to solve for is final y position, maximum height. Okay, maximum height. That's what I'm trying to solve for. Velocity of the maximum height is 0, but maximum height we need to solve for it. So if you look at this equation, guys, we do know the final y velocity. We do know the initial y velocity. We know the acceleration. We don't know the time. But are we solving for time? No, we are solving for maximum height. So this doesn't help us. Let's cross it out. Let's cross this guy. It doesn't help us. Let's now write down the second equation. Y is equal to y naught plus v naught yt plus half a yt squared. I don't know the final y position. I do know initial is 0. Initial y velocity is 10. Time is an unknown. Acceleration is a known. Time is an unknown. There are two unknowns. Final y position is an unknown. And then the time is also an unknown. So I can't solve for one unknown using two equations. This doesn't help me. I can't solve for two unknowns using one equation. So this doesn't help me. Let's look at the third one, guys. V squared is equal to V naught y squared plus 2a y minus y naught. Do I know the final y velocity, Vy? Yes, it's 0. Do I know the initial y velocity? Yes, it is 10. And do I know the acceleration? Yes. Do I know the final y position? No. Do I know the initial y position? Yes, it is 0. So now I can easily solve for the final y position using this equation. Just do the substitution. 0 is equal to 10 meters per second. Don't forget to square it. Plus 2 times acceleration negative 9.8 times y minus 0. So 0 is equal to 100 meters squared divided by second squared plus, actually it's 2 times 9.8 is equal to 19.6. It's negative times y, and you can subtract 100 from both sides of the equation because I need to separate y on one side. This will cancel out with that, and I get y is equal to 100 divided by 19.6. Wait, what happened to the negative signs? Okay, so you have negative on the top and the bottom. You can simply ignore it, but even if you put it, it will anyways cancel out. Meter squared divided by second squared divided by meters per second squared. So give me 1 second until I put these numbers into my calculator, guys. You don't have to do this. You don't have to wait for me. You can do it. You should get 5.1 meters as the final y position. Okay, so look, see what I did. I choose the correct equation. I have the correct equation, and then 100 squared plus 2 times negative 9.8 times final y position, and I just simplified it. 10 squared is 100, 19.6 divided both sides by 19.6, and that's my answer for final y position. Okay, alrighty, so now let's do question number 5. You throw a rock straight down off a cliff with a speed of 20 meters per second. 2 seconds later its speed is... Okay. Now let's draw the diagram. Let's assume this is the cliff. And you throw the rock straight down. Now you're not dropping it. You throw it. When you throw an object, when you drop it, then it was 0. But when you throw it, it's not necessarily 0. It says you throw the object at a velocity of 20 meters per second. You throw it down. So meaning it has an initial velocity. V naught y is no longer 0 because you don't drop it, you throw it at negative 20 meters per second. And we know acceleration is equal to negative 9.8 meters per second squared. And the time is 2 seconds. You're asked to find out the final velocity at the end of 2 seconds. Okay, so let's look at the first equation, because that's where I always start. I just start with the number 1. And then I do the regular thing I do, crossing out. Do I know the final y velocity? No. Do I know the initial? Yes, negative 20. Do I know the acceleration? Yes, negative 9.8. Do I know the time? Yes, 2 seconds. This is my yes, guys. Seconds. Okay. So I'm going to write down up as positive. That's why I have negative 9.8 and negative 20. And I'm going to do the substitution. Negative 20 meters per second minus 9.8 meters per second squared times t is equal to 2 seconds. Simple as that. Your final y velocity is, so you don't have to wait, you can pause and do it. (39.6). Don't forget it's negative because it's going down. You throw it down. Okay, so this is the final y velocity. Alrighty. You can see as we expect it's negative value, and also as we expect it's greater than the initial 20, because when the object is moving down, it's speeding up. Velocity is down, acceleration is down. Same sign for velocity and acceleration, so object is speeding up. Makes sense, initial velocity is 20, final is greater than that, 39.6. Okay, so our answer makes sense. So let's do number 6 as well. A hammer dropped from the roof of a building takes 3 seconds to hit the ground. how high is the building? Okay, so let's draw the diagram. The hammer is dropped. Now it says it's dropped. When you drop an object, initial velocity is 0. You don't throw it, you just drop it. So this is the building. Okay. You drop it down. So V0y, I'm going to immediately write down it's equal to 0 because you drop it, and it takes time is equal to 3 seconds to hit the ground. And we don't know the initial y position, but we do know the final y position is equal to 0. Okay, and acceleration ay is always negative 9.8 meters per second squared. We take up as positive y. Okay. Now this is all we know. We know the initial y position. We do know the initial velocity. We know the time. We know final y position. We know the acceleration. So we are trying to find out the initial y position. That would be the height of the building. So height h, because this is 0. If you know the initial y position, you automatically get the height of the building, right? So if you want to try the equations, you can start with the first equation, as I always do. Well, if you look at this one, we don't know the final y velocity. We do know the initial. We do know the acceleration. We know the time. But this gives you final y velocity. Is that what we are solving for? No, we are trying to solve for the height of the building. Initial y position, that's what we're trying to solve for. So this one doesn't give us the answer. This equation does not give us the correct answer. So you can cross it out. Let me get some space here. Let's write down the second equation. Do we know the final y position? Yes, it's 0. Do we know the initial y position? No. Do we know the initial y velocity? Yes, it's 0. Time, we know the time. We know the acceleration. We know the time. So there's only one unknown, that's initial y position. And that's what we are actually trying to solve for. Okay? So we can use that, do the substitution, that is 0 because it reached the ground, bottom level, final y position is 0. Initial, we don't know, initial velocity 0, you drop the object, half times acceleration negative 9.8 times time is equal to 3 seconds. So 3 seconds and you square it, okay. Now you need to calculate it. You can pause and calculate. So 0 is equal to y0 minus, so y0, let's solve it first, 0.5 times 9.8 times negative 9.8, guys. 0.5 times 9.8 times 9, you'll get negative 44.1 meters. Okay, you can say second squared will cancel out with second squared. So initial y position is equal to 44.1 meters because we have to add that number to both sides. Okay, alrighty, so that's our number 6. Okay, so we discussed number 4, 5 and 6.